All right, great. So, yeah, one note. I will repeat again to the stream that if you go to the wiki page or to the front page of the project, you should have a button to request the access, and please do that. I cannot grant you permission to access the wiki otherwise. So those of you who are trying to add papers to the wiki and were not able, which is everybody, please request the access, and then you will do it for next week. So for this week, because we didn't have the papers and I didn't sort it out early enough, I have a lecture. So I kind of have a discussion with you about like the future of mobile computing. All right. So we will sort of do a generic discussion of what mobile computing is and what might be the future of it. Okay. So let's load the slides. All right, so those of you who did the mobile course with me last year, or 2 years ago for that matter, know some of those devices. Who recognizes that device? What is that device? So this is an open hardware and open software mobile phone with touchscreen, which came about around the same time as the iPhone, the first iPhone. So there was a project called OpenMoko, which was porting Linux and some of the open hardware and open software to create a handset for the public, which is completely open. Before that, all the handsets for the mobile phones were kind of closed by the telecom manufacturers. And iPhone was the first phone which was sort of not done by the telecom manufacturer. It was done by a non-telecommunication company. It was done by Apple in collaboration with telecommunication companies. So Apple was not selling iPhones outside of the telco business, right? You have to buy a plan and you have to buy a kind of a telecom contract with the phone. You couldn't just go out and buy the phone like we do now, right? So you can go to a shop and buy any phone which is sort of unlocked without the operator, and you can use it with any operator you want. But before that, it wasn't the case. You have to lock yourself to a particular operators, and the phones were locked to that operator, right? So if you bought, say, an iPhone with a particular telco operator, you cannot use it with anybody else. You cannot just switch the SIM card because the phone was locked. So there was the whole business of unlocking the phones. Do you remember that? Yeah. So that was the first sort of push towards opening up the platform. And the project failed. They couldn't get sort of enough traction with the customers for a lot of reasons. One reason was that it actually didn't work as a phone, like you couldn't make the phone calls because they were still working on it to make it possible. So you could only develop for it. It was sort of a developer preview. The other fun thing was that to charge the battery, the phone has to be running. So the operating system has to be running to be able to drive the drivers who are charging the battery, right? So if your battery went flat, you were effectively not able to charge the battery because you cannot boot the phone to charge the battery. So when we were buying the phone, we bought two just in case. And often it was the case that one of them, you know, the battery went completely flat and you cannot boot it. So then you have to take the battery out, put the charged battery in, boot it, start charging it. While it is being charged, you can take the battery out because you have the OS booted, so the phone is actually working. So you can take the good battery out and put the flat battery in and then charge it. Right? So it was quite funny. Anyway, this is one of the, you know, first mobile phones which was installed in cars, right? It was sort of a portable handset, but it had kind of a box with the battery and with the transmission antennas, which were quite big. So people would not able to walk with them, but they could be installed in cars, right? So the first mobile phones were sort of mobile in a sense that you can be driving in a car and have a conversation, right? but they were not the same as we have now, that we have a very portable handsets which we carry in our pockets. They were quite bulky. So the history went from feature phones which were very dumb. You could only make phone calls and SMS messages. Then you had a little bit more. You could have internet connectivity as well. You could have limited browsing capabilities or web. And that's sort of the transition. So we went from something like this through a more and more advanced feature phones to something that is actually in the shape of the current mobile phone, right? So mobile computing kind of evolved. So it's not only the phones, but it's also any other devices. So we have, laptops. The original laptops were, again, pretty bulky. They were very cumbersome to carry around. Some of the gaming laptops never changed, like they're still bulky and heavy to carry around. But we do have computing devices which are very lightweight, very thin, very small. We have, computing devices on our wrists. I mean, I have a lot of apps. There is an app store for the watch, right? And you can install different apps for a particular, I'm using Garmin, but there are different Android Wear and so on, where you can browse the shops for apps on the watch, right? In the past, if you thinking about this, right? First mobile phone in the car, pretty bulky, and you say, well, it will be miniaturized and we will have apps on our watches. It was kind of a leap ahead, right? But it is a reality right now, right? We do have smart wearables that we carry everywhere with us. So I will let you read the sort of interesting fact. And the bottom line here is that we have devices in our pockets which are the same powerful as laptops a few years back. And if you think about, fast forward a little bit, you don't need more computing power. We will have more storage and we'll have more computing power, but in a sense, we don't need that, right? I had a discussion yesterday with my daughter, 2 days ago, and she was asking me why some iPhones are called S and some are not. Like she said, my one is 5 and my friend has 5S. What's the difference? And I said, well, S stands for speed probably because Apple released iPhone 5 and then a few months later they updated it with a faster CPU and faster memory bandwidth, and it's faster, right? So I told her it's probably for speed because the 5S is faster, right? And she was like, okay, so what does it mean? It charges faster. And I said, no, actually it charges probably the same as 5. It doesn't charge faster. So she said, so what does it mean it's faster? And it's like, yeah, I didn't know how to explain to her that, in the old days we have very slow phones, and if you play a game, it's laggy and, things are kind of laggy and slow. And now, like, she plays games and everything works fine. So she says, okay, what does it mean it's faster, right? It's like everything is the way it should be. So the only thing she was thinking of is that it charges faster, right? So we already have devices which are fast enough. I mean, you don't need any more speed. Like, you have multitasking and you're playing games with no lag and, you can cramp a lot of things into it. Maybe if you have really complex AIs and really complex games, you can benefit from faster phones. But, that's mostly about the GPUs as well, not the CPUs anymore. So, the fact is that if Apple ported the Mac OS to ARM, they could basically run most of the consumer MacBook Airs on the ARM CPUs, on the same CPUs as the mobile phones are running, right? The prosumer ones, the MacBook Pro and some gaming laptops, yes, they wouldn't be the same yet because the mobile CPUs are still slower, but the difference is not that great anymore. I mean, the difference, like, it's catching up, right? So you can sort of imagine that we will have sort of blending, right? Of course, cloud computing will always be more powerful and more, you can store much more and process much more. But in terms of personal computing devices, our PCs and our laptops and our mobile devices are kind of blending. They becoming as powerful as we need them to be with the margin, right? So there are still some aspects which are typical to the mobile, right? So one is the battery, okay? So how can we mitigate the battery consumption? You probably read some papers, like some of you might be interested in picking some of the optimization for the battery and so on. But you know, what do you think? What can help with the battery? We can have better technology, better battery technology, so we can, in the smaller form factor, cram more sort of power, right? Storage. So sometimes the industry talks about storage capacity per gram or per kilogram of battery, right? So depending like how heavy, you know, how small and heavy the device is, there is certain limit. So we've been kind of reaching a plateau of how miniaturized batteries can get per particular power capacity, right? So we have kind of a, you know, watt per gram or something like this. What else can happen? We can get a better, less power demanding hardware. So CPUs, the mobile CPUs are kind of more efficient. We can have improved processing, so we can make the software be smarter and not waste the energy, right? So for example, we have quad-core, like most of your phones are probably quad-core, right? So what would you do to conserve the battery? You can say, okay, we can turn some cores off, right? So if you have 4 CPUs, and you browsing your emails, so you have 4 cores on your board. To conserve energy, you can say, okay, to browse emails, I only need 1, right? I don't need these, so I will turn them off, and I will let you read emails on just 1, right? So we have energy savings. So what's wrong with that, with doing that? Say it again?
To start up other cores again?
Yeah, so one might be kind of a start-stop cycle, right? I mean, when they are running, we have to finish whatever they're doing, stop them, and then when we're starting them, we have to say, okay, now you have that, right? So yes, so there is some kind of energy wasting for the life cycle of stopping and starting. What else? So let's say you are a developer, you're writing an app, right? And you're writing an app which, I don't know, it's some sort of usability app. And you may want to have 1 thread for dealing with graphics and 1 thread to deal with interactivity and 1 for AI, okay? So you say, okay, I have an iPhone or Android which has 4 cores. I know if I have more than 4 threads, I will have to do multitasking on single thread, on single core, right? But if I know I have 4, I can kind of play up to 4 threads to be very efficient, right? But if the operating system is managing that for you and turning some cores off, you don't know how many you will have. So you don't know how many threads to start to be optimal, right? Should you combine the graphics and physics with the UI or something in 1 thread or not? Like, how do you program it, right? So if OS is managing the hardware and turning things on and off, you don't know as a developer, you don't know what is the platform that you're working with, right? You cannot optimize it. You cannot make it efficient, right? So that sucks, right? Like if I know I have 4 cores, I can optimize my app to be optimal on 4 cores. And but if the operating system messes up with that, I don't know, right? So what Apple did with the iPhone 7, they said, well, actually, in the past and currently, and a lot of manufacturers are doing that. Operating system can turn off some unused cores to reuse energy, right? But what they've done, they said, well, okay, let's do something different, right? Let's create a CPU design which has 4 cores, but we will only have 2 running at the time, okay? So we have 2 which are running kind of a low power, low speed kind of thing, right? And then we have high performance 2 cores, right? So now the programmer always know, okay, there are 2 cores. I can have 2 threads and they will run efficiently because I can, the operating system can schedule them on 2 cores. But the operating system decides if the tasks at hand are very performance hungry or whether they kind of a low cycle performance, right? And if it's like reading email, the OS can switch to the low performance ones and run whatever it's running on those 2 cores which are low performance. And the high performance, high power consumption ones are asleep. But if you turn on the game or something that requires a lot of processing power and these ones are kind of getting to their limit, then the OS switches and swaps whatever they were running on those 2 and runs it this way, right? So this way the OS manages the power consumption, but from the programmer's point of view, you basically are given always the same resource. You always know the number of cores you have at your disposal, right? So you know that you have 2 high performance and 2 low performance ones, which the operating system will be, switching, and then you have, GPU, which is kind of always the same, right? The IBM cell architecture was similar. They had multi-core chip, which had, I don't remember exactly, but I think 2 kind of low general purpose, low performance dice in it, and then 6 the ones which were high performance, and you can turn them on and off depending whether you need it. So there is innovation in kind of chip design and CPU design to balance the needs of the programmers and developers to know what they're working with, so they can plan their multi-threading properly, and the operating system which can take care of managing the resources efficiently as well. All right, so those slides were done last year, but not as much has changed actually, right? So the life cycle for CPUs and so on is around 18 months. So every 18 months you have sort of like this Moore's law, doubling of number of transistors we can cramp in the particular volume of silicon, right? Which means usually you have sort of doubling of performance. It doesn't continue this way, so the cramming of the transistors doesn't translate directly into the performance growth, right? So we don't have every 18 months the double of performance anymore, but again, we sort of reached a little bit of a curve which is less angled than before. Before it was like pretty flat. It was like every 18 months we were doubling it, and now we kind of are flattening out because we're reaching some of the thermal and thermal issues and kind of the speed of light issues, right? So the information cannot travel, faster between particular dimensions that we're dealing with anymore. But this is still true. So you're probably running quad core. You're probably running an equivalent of 2.2 gigahertz desktop CPU, 64 bits. Apple, with the latest OS updates, actually forbids 32 libraries or apps anymore. You have to recompile everything to 64 bits. So there is no more 32 bits apps on iPhone or on their platform anymore with the latest OS updates. It probably has more storage than your old laptop, and the camera is probably better than the one you had in DSLR, which you bought 6 years ago. So the sensors quality is probably better. In terms of resolution, we had it for a long time. So DSLRs, any of you is into photography? DSLRs, resolution-wise, were kind of always behind the innovation in mobile phones. The resolution-wise, megapixel kind of wise, they were either worse or the same. But they have kind of good the sensors which you use in the DSLRs are bigger, right? So they can basically take more light into the surface. So even though the resolution, like the amount of elements you cram into the surface, might be better, like per inch, on the mobile phone sensors because they are more dense, it actually turns out that if your light detectors are bigger, it kind of translates the color rendition a little bit better. So even though your resolution is sort of smaller per inch, you can render the colors much more accurately if you have larger sensors because you have more light coming in. So DSLRs, even though the resolution-wise they were kind of always behind, they always rendered the light colors a little bit better than the mobile phones. But you can do a lot of tweaks. You can do a lot of filtering and a lot of approximations and so on, and use the kind of different color gamuts to kind of render the high fidelity sort of color spaces on the mobile phones now as well. So yes, the DSLRs are still winning. Like if you want the best possible rendition of the color spaces with different shadowing of different colors, then DSLR are still better. Yeah, how often do you use it to make calls? Not too much. In fact, I have a Nexus 1 Google phone, which after like a couple of updates, something broke and the phone app actually crashes. So like if someone calls me, sometimes I can pick it up and talk, but more often than not, it actually like freezes the phone or crashes the app. And with the latest January update, I've noticed that it happens like almost all the time. So a friend was calling me yesterday, and I could see him calling me after, like he called, like not while he was calling. So I had the kind of with the delay that, oh yeah, you had a call like half an hour ago. It's like, okay, fine, you should have called when the phone call was happening. So then I tried to call him, and first the phone froze, then I rebooted, then the app crashed, then I tried again, the phone froze. It's like, I cannot call him, right? So I had to use my wife's phone. So it's pretty useless, but I don't call on my phone that often, right? So I still carry it in my pocket and I still use it. It's just that I don't really can make phone calls. It's a little bit like OpenMoko, right? So, I stay with touch with family and friends, yeah, using apps. I don't need to call them, right? So yeah, that's kind of a little bit of a controversial question. Like, do you think it will be possible for us to use phones as a developer machine and program on it? If you use the phone and plug it to a big screen and plug it to a keyboard, would you be able to develop software on it with the current phones that we have? I think you could. Like, they are powerful enough. You probably wouldn't run Unity on it, like something that is, or Unreal, something that is really memory and processing heavy. It would kind of lag. But for like Android Studio or something, I think, or using some text editor, you would be able to develop something and compile it, right? So why don't we do that? Why don't we have this sort of development setup for a tablet or for a phone? If technology is not the limitation, what is? So I suspect it's because of the kind of a product partitioning, right? So phones and tablets are sort of a consumer market for media consumption, right? So we use phones and tablets to make photos and to consume photos and to use Facebook, not really to do like, app development or content development or, video processing and so on. Although there are some apps which allow you to kind of do video processing these days on the phones or tablets as well, right? Because a lot of people are using that to stream or to do some media production for YouTube. But historically, the market is kind of partitioned. You have the prosumer market, which are the developers and programmers and graphic designers and media producers and video editors and so on. And you have the consumer market, which is the people who consume media and kind of browse stuff and don't really produce much, right? Although, as I'm saying, the distinction is very blurred because of YouTube. A lot of consumers are now producers as well, and that's why there is a small emerging market for graphics editing and video editing done on the phone directly, right? But historically, you had a different equipment to do that. You had more powerful laptops or workstations to do video processing, for example. But you could imagine that you don't need a laptop anymore as long as you have your phone, which is powerful enough, and you can plug in a big screen and a normal keyboard to it, right? And it may happen. Right? Wearables, we talked about it, rings, that's the next probably thing, and like wearables on your t-shirts and stuff, right? If I tell you, okay, there will be an app store for apps on your t-shirts, right? It sounds, oh yeah, maybe, but it sounds very science fiction kind of thing. But it's the same, it's the same as I was talking about apps on the watches, right? If you mentioned 10 years ago, 15 years ago that there will be, app stores for apps running on the watch. It is sort of far-fetched, right? So it might be the same here. We don't have app stores for rings, but they usually you use similar Android Wear OS, so you can have particular apps running on a very small real estate. You just need to plan the UI properly, and also there is a limited resource. The CPU capabilities and so on are kind of limited, mostly because of the size of the battery. You don't want too much power cramming the battery life there. Yeah, projection technology. I will have, yeah, we can watch the video. So I will. All right. So what's wrong with that ad? What do you think? So just from looking at it, it kind of looks too good to be true, right? Exactly, and you can see that it has been faked, right? It is not the real demo, it's actually like an overlay on top of the skin, right? So do you think you could get such a perfect close range projection from a projector? That, you know, the square would look perfectly square, so close to the projector. Is it physically possible? It probably isn't, right? We do have short range projectors. We have one in the VR lab for the sandbox, but you still need some space. You still need some, you know, distance, right? And the distance between the beginning of the projection and the perfectly squared image was like really tiny, like few millimeters, right? That is probably not possible, right? So those two things already trigger some warning signs, okay? So there is kind of a funny story with this. Yeah, let me just redo with this because, you know, the bracelet went kind of viral a few years back. And then, of course, it was sort of a campaign which was trying to get people to fund the project. But, you know, realistically speaking, it is probably very hard to achieve something like that, right? With this form factor and with the current projection technology, right? So the project failed. And then, you know, it was relaunched again in 2016, and that's when I learned about it. I didn't know about the original one, right? I learned about it from the Kickstarter, and it turned out it was a scam using the original videos from the previous 2 years project. So the original people, you know, they you know, told the Kickstarter that it's a scam because they are violating our copyright, right? So. So, you know, we have a couple of kind of fun things about it. So one which we already discussed. So it's the, you know, what is physically possible and what's not. So you always have to make sort of reality check. There is, and there are some sort of fallacies that we often talk with Simon about. So you can read them as well. So when someone is making an argument, then you can become a victim of one or many of the fallacies that the author is trying to use to convince you to their point, right? So in this particular case, you have this sort of potentially authority fallacy, association fallacy, and then there are ways for mitigate our cognitive bias, right? So you have to kind of train yourself to be a little bit more skeptical, to separate what is real and what you wish to be real, right? And we fall under a lot of you know, cognitive biases automatically. So it's kind of good to, yeah, to check the links. All right, so coming back to the discussion, we have, you know, currently I have phones with like 256 gig of storage. There are phones with 512 already, with half a tera. If you fast forward 1 or 2 years, you will have, you know, 1 tera or 2 tera easily in your mobile device, right? So if you have 2 tera in your mobile device, that's, you know, way more than you can store on the Google Drive, right? And you kind of carry it with you everywhere, right? So it opens up some possibilities. It will probably be, you know, not quad core, but 8 cores or more. And it will have, yeah, the GPUs, again, they, you know, the desktop GPUs were leading the pack for many years, but usually you have the economy of scales, right? So if you can sell, you know, millions of something and thousands of something, you will invest more time and more energy into something that you can sell millions of, right? So if you are a GPU manufacturer and you can sell, you know, millions of GPUs to mobile manufacturers for their mobile devices, you naturally invest more, right? So the innovation happening in the GPU space is actually driven more by the mobile GPUs than by the desktop ones. There is, of course, desktop GPUs, and you know the push over there is actually not from. Okay, so historically the biggest market was the gamers, and the gaming industry was sort of driving innovation there, which is still happening. But there is a more kind of a novel sphere of using GPUs for general purpose computing, especially with the AI and machine learning, where you know you see NVIDIA and other manufacturers kind of blending the space, right? So you can buy a very high-end GPUs for doing general purpose computations these days. So what does it mean? What do you think? Like if we have really powerful devices in our pockets, which exceed your need for storage and processing, and they are kind of widespread, what does it mean? What does it mean for cloud computing? What does it mean for us as a society? Those are kind of interesting topics, right? And interesting questions. We don't know, like we can hypothesize certain things, but you know, sky is the limit. We don't know what that means. A lot of things that you currently have to do with the cloud, you could potentially do with distributed computing among the peers that are around you, right? If you want a reliable backup, you could spread information around the circles that you're around, right? So currently, if you want some sort of reliable backup of your photos, you're using Google Drive, right? You're using some sort of a facility in US or in Ireland which stores your photos in kind of redundant fashion. But if you live in Norway and you have a lot of Norwegian friends and you know everybody is carrying 2 terabytes in their pockets, they can give you a couple of gig of storage to back up your stuff, right? And you can duplicate it all over the place. And you don't need to spend you know, resources of transferring it all the way to the US. You can do it via some local communication protocols here, right? Because we have this class for semester, you know, and we kind of meet here regularly. You can back up your stuff with the people who are here. Like if everybody says, okay, you know, I will give 20 gig for shared storage, and I get back 20 gig for secure storage for myself, and it's encrypted, nobody can fiddle with it, and you have a lot of redundancy, it's fine, right? And it doesn't use a lot of energy, it doesn't use the big pipes to go with the transfer all the way to US or somewhere else. You can kind of do it locally. So that's potentially one example, right? Yeah, so we discussed this one. We discussed what are the problems of turning on and off the cores and the resources. We discussed a little bit of that. So, you know, battery is one, right, for sure. What else? What else are limitations of the desktop versus mobile? Well, processing speed, I don't think that's a huge limitation. It's still a difference, but I don't think that's a limitation, right? Storage, potentially, right? You can have a really fat NAS setup at home, which you cannot really do on the mobile, right? If your mobile has 2 terabytes, at home you may have 200, right? Because at home it's easy, right? You just have a kind of a fatter box with SSDs and you can store 200 tera, right? It'll always be the case. It will always be the case that even though in your mobile, in your pocket, you can have X, in your home you can have 10X or 50X, right? So storage-wise, yes, it's probably a difference. What else? You carry the device with you, so you have sensors and you have kind of portability. So as I said, if you want kind of a secure duplication of your data from home, you have to transfer it. You have to have a fat pipe going from your home somewhere, because your data store is stationary. Your data store in your pocket is movable, right? So if you want more redundancy, you just go to meet other people, right, and kind of store stuff with them, right? So in terms of redundancy and kind of a backup, I think mobile mobility kind of gives you an edge, gives you more than the stationary ones, right? Yeah, we discussed that, right? What are the reasons why we're not using the mobiles for programming? One reason is that, you know, we don't have tools, we don't have software. You know, Android Studio doesn't run on Android OS, right? Compilers, you know, Linux, Android in itself should be fine. Like GCC is running on Linux, so you should be fine running GCC on your phone. But we don't really have kind of a nice support for that yet, right? And one reason is, you know, the market is probably small. The market of programmers happy with their laptops and desktops is by far larger than the niche market, which has sort of a need for programming on the phones, right? There is a kind of a generation of developers which are sort of moving around. They don't live in one place, they kind of roam around, and they are very mobile, right? They would benefit from something like that they could run you know, development on their mobile devices, but they kind of fine as well with the current laptops, right? You know, it's convenient. I don't need to carry a larger screen, right? I can carry this laptop and program on it. I already have a keyboard and a screen. If I had to carry a mobile phone, on the mobile phone screen and the, you know, touch keyboard, that's no way to program. You need a physical keyboard and a physical screen, but it's kind of inconvenient to carry that currently, right? So, you know, that's the kind of overarching question. So when you're reading papers and when you're kind of looking at different materials, you can do it from two sides. You can do it exclusively kind of bottom up from the technology layer, like what is technology giving us? What is the technology enabling us, right? And a lot of innovation is happening this way, right? We develop a new tool or a new thing, and then the kind of a systemic social aspects kind of follow. So technology is often driving a change in society, but sometimes the kind of the social needs are filled in by the technological developments. So you can look at it like from two perspectives. You can look at it from social perspective, like what is that, you know, it's sort of like think sci-fi, okay, science fiction. What is that we could do if we had the technology, right? What we would do if we had teleporters, okay? How it would change, how the world would change if we had a particular technology available, right? So if you're thinking about mobile, you can think about it, okay, what would change if I had a device which is as powerful as my laptop and as huge in storage and speed capacity as the current desktops in my pocket? What does it mean? What would that enable, right? And then you can see, okay, what is the technology doing, right? So I have what is this? I have two papers that I will show you, and they kind of discuss the concept of governance with the technology that is behind it. Okay, so we were not able to do certain governance models because we didn't have the technology. And now the technology enables us to have particular governance models, okay? So we pose a question, is the mobile phone allow you to participate more in your kind of local governance or, you know, country governance? They do, right? They make us more connected. You can participate, and probably many of you do, in many groups which formed on Facebook and so on for different areas. And you can easily keep track of what is happening and kind of participate, right? Before Facebook, sure, you could participate in some groups too, but you know, you have kind of a limited afternoon, right? You go to a particular club, you meet with those people, and then, you know, a day is gone, right? With the phone, I can participate in hundreds of different groups and spend, 15 minutes on each of them, and it's still doable. In the past, to really participate, I kind of have to physically meet with people and go to places, right? That's taken away. So local institutions are doing that, but they're not doing it good enough yet, right? What if the link between you and the Jobbik Kommuna is like same as you have currently on Facebook, right? You just see what's happening, what they are voting on, what projects are running, and you're kind of participating. It is possible. So, how would the mobile technology allow you to kind of participate in your kind of more country level decision making? So this is, this is almost 50 years old paragraph, okay? So the guy says, one of the marvels and advancing technology of electronic computers indicating devices and recording equipment. Some, in fact, have predicted that within 20 or 30 years, every home will have a console tied into a computer upon which the children do their homework, the housewife will make their grocery list, and so on and so forth. And the husband will pay the family bills. Such a computer console also could be used to record political decisions, giving each voter the opportunity to cast his ballot on every issue and have it recorded through the machine, right? Okay, so 50 years ago, that was completely science fiction. The guy is saying, oh, maybe in 30 years we will have something like that. Today, that's reality. Like, it is happening, right? It's also quite interesting, it is a little bit sexist, right? The housewives are doing grocery and the men's are paying the bills, right? So, the language is, you would probably not go far with that language in modern times. But anyway, so, we have everything apart from the last thing, right? Why we don't have the last thing now as well? We can pay bills, we can do grocery shopping, we can do everything on the phones. The grades from my kids are on the internet. I can check what homeworks they have to do and so on, right? It has happened, with the exception of the last thing, right? Why we cannot vote, on every issue from our homes? Many reasons, okay? Many reasons, most of which are not technology related, right? Technologically, it is possible. But, first of all, you don't really have time to read all the issues they have to be dealt with, right? You might not be interested, okay? And then sometimes making decisions based on just voting is not good. Like, you actually have to have experts making some sort of evaluations, right? If we make all the decisions based on voting, you may not end up with the best kind of solution. Voting is good for some things, but not for everything. So there are some issues with the last kind of statement, but technologically it is possible. So there is this concept of liquid democracy, right? Have you heard about it? So liquid democracy is basically like democracy, but you can change your mind at any point. Right? So normally in democracy you say, I believe this particular representative is representing my beliefs and my point of view, and I want him to represent me in the parliament, and for 4 or 5 years you kind of do the votes and you say, okay, I'm delegating all my beliefs and all my trust into that person or that party. And then for 4 or 5 years they kind of do whatever they want, right? And then you're out of the democratic process. And then when the new election happens, they ask you again, okay, now you can change your mind, right? So liquid democracy is like that, but you can change your mind every minute, right? You give a particular vote to someone to represent you, but at any time you can take it away and give it to someone else. So if someone you gave votes for are not doing what you were hoping for them to be doing, you can take the votes out and recast the votes to something else. So the liquid means it changes, it's fluid, it's always changing, right? So the people are kind of observing what is happening and they can cast the votes at any time. And the ballots are kind of recalculated, right? So it's sort of like, okay, imagine that you deciding, okay, who is the prime minister, and majority of Norway said, okay, that should be the representative of Norway, right? And let's say she or he wants by 65% to 35, okay? And then at any point, people can change their mind. At any point, somebody else can take over, right? So if the person who is given the votes kind of does something that people dislike or don't believe it's good for the country, they can cast the votes again, and then someone else takes over. And those things are kind of fluid, and that's why it's called liquid democracy, that it kind of changes all the time. So there are two papers. One is a diploma thesis, which is sort of an equivalent to a master thesis. Okay, so it is quite technical. It's written from a computer science perspective. It talks a lot about technology and a lot about underlying implementation of how that could potentially work, right? So it's a kind of an example of a master thesis, let's say, from 2012. I would like you to read it, but because of the math and because of the crypto primitives which are used in the write-up, you don't have to read everything in a lot of detail, right? If you understand public-private key cryptography, that's fine. You don't have to go into details of how it is done and how all the details are working and how it is kind of motivated, right? Just understand the concept. So the first one is quite technical, but I don't want you to get all the technicalities out of it, right? But if I ask you, okay, what is a hash tree? Then you should sort of know, oh yeah, hash tree is sort of like a tree where keys are hashes, okay? That's enough. You don't need to know all the other details. He uses a lot of formalisms, so scan over them. Don't like try to understand all of it, right? Why I'm convincing you to read that paper? For many reasons. One reason is that you will learn a little bit about liquid democracy, which is kind of cool. The other one is you will see how you can structure your master thesis, how the master thesis looks like, what is it about. You have some sort of umbrella concepts that you have to explain, and then you have your contribution. You have what you actually, working on as a sort of part in the big picture. So you have a big picture, the description of what you're working on and why you do the work. And how would you do that? And he kind of describes how he implemented it, right? So that's the first one. And also, the first one is let's say it's a master thesis, right? So this is sort of like a half a year worth of project work, right? So you do some reading on the general topic, but then you have to narrow it down to the work at hand and sort of deal with it and then place it in the context of the thesis. And that's sort of the scope that you're aiming with your projects in next year. The second one is similar topic, similar discussion, but from the PhD point of view and from much higher level, right? So the first one is kind of very technical and describes how and how would it work. That one is kind of stepping outside and looking at it from a more general social aspects, right? That one is it's not a PhD thesis. It's just an article, which then is part of the thesis, right? When you're doing a PhD, you're working for, say, 3 years, and you're kind of developing kind of a bigger picture of something, and you're contributing to knowledge by publishing a couple of papers. So usually in Jovik, you have to have 5 or 6 published papers, which you kind of put together and put like introduction and ending, and you sort of have a body of kind of a body of research work that you're contributing to science. So this is one of the articles. So I want you to pay attention to the language and to the arguments and how he structures the article, right? So the first one is interesting because of the technology and an example of a master thesis. And I do encourage you to read other people's master theses, which are kind of good. And this one is quite good. And this one is just an article, right? So it's kind of a condensed way of arguing something, which is much more concise and succinct but at the same time, it's sort of much more from the higher level, right? So both articles are kind of good. This one is shorter, so it will take you less time to read. This one is longer, but as I'm saying, don't read it through from cover to cover, just kind of go quickly. Like if you understand, public-private key, you can scan through it. Don't have to read the whole thing. Just understand the structure and how it is organized. So we will kind of, discuss it a little bit after you've read it, right? So we couldn't really discuss any of the papers you were reading and planning for the course because we didn't have the wiki working. So please do the wiki thing like as soon as possible, preferably today. So you have access and then other people can see the papers and we can read some things. And please read those two papers, right? So what we will do next week is we will discuss those two papers. What are the good ways or bad ways of doing things? How do you explain kind of a technology, for general purpose audience? And what we will do is we will pick some articles from the list that we will kind of discuss a little bit more. And then we will start formulating the questions, right? So this is still sort of a warm-up kind of exercises for us to formulate exactly what we will be arguing through the essays, right? So we will not write anything until next week. We will start after the next week. And next week we will spend kind of discussing some of the questions and how to formulate the questions, right? So for example, the thesis here doesn't really have a kind of a well-defined title, okay? So liquid democracy, okay? That's like a keyword. And then to understand what the thesis is about, you have to read the abstract. And then you understand that it is about implementation of the liquid democracy paradigm using the electronic system, okay? The second one says, through liquid democracy to sustainable non-bureaucratic government. Okay, that gives you more, right? That is sort of again, a kind of a line explaining something that someone is using a liquid democracy for a sustainable and non-bureaucratic governance, right? So it still leaves some space for interpretation of what is it exactly. Is it like an implementation? Is it a digital implementation, or is it an argument for it? Is it the analysis of a social construct related to it? You don't know. Again, you have to read the abstract, but it's a little bit better, right? So the second title is better than the first one because it kind of gives you more of what it is about. And we will discuss that next week from the papers that you have suggested and from some of the papers that I will put into the wiki myself. Yes, so I think that would be it. We didn't have a break, so again, we should have breaks, so apologies. But if we finish a little bit earlier, that will kind of, end up correct. Do you have any questions? So there are kind of two takeaways from this lecture. One is try to think when you're reading papers of what it means kind of on the social level. Not only what it means on a technology level, okay, we can do this now because it's possible, but also like what we as a society can do now. What can change because of the technological developments with wearables, with tracking and so on. What does it mean for privacy? What does it mean for interacting with others? How the structure of society can change if we have more involvement or more freedom or whatever that is that you're reading about. And then like read it from the technology side of things as well. The other one is read those two papers and check how they are structured, how the author is making the argument, what sort of language they use, and how it is written. How is the PhD article written, and how is the master project written, right? The master project is kind of written in more simple language, easier to follow and kind of well explained. The PhD one is more succinct but at the same time sort of better structured. Like he he makes more references to what it means, whereas the master student doesn't. He sort of takes certain things for granted and sort of makes assumptions without really questioning things, right? Both are good. Both are well structured and kept at certain level, but it's kind of nice to read them next to each other because they sort of demonstrate some maturity of the PhD student writing that particular article, and you can kind of learn from it, right? Right, so questions? If there are no questions, make sure that you ping me with the request for the wiki access and put the papers in as soon as possible. And then next week, I will kind of list what will be the papers that we will discuss. And then those people who read them will kind of participate. I mean, everybody should read them, but yeah, from experience, those people who were suggesting them and read them, they are more safe to count on. But you know, I will list some papers for you all to read. You don't have to read all the papers, so read those two and some from the list. Okay. So the list will be, I don't know, I will probably put like 5 or so out of all the papers that we will have in the thematic page. And then from next week, we will sort of discuss, okay, how we're gonna formulate the essays, and then we can do that. And because the essays are kind of done in parallel, like we will kind of go on. So everybody's kind of writing, and then everybody's arguing, right? Because it's written in the written form, we don't have to have a schedule like you have in the game specialization where 2 people kind of arguing with each other. Like this is more parallelized because we just do all the writing. Like we dedicate like say 2 weeks for a first essay, and we kind of do the counter arguments after that, right? So we'll have some sort of schedule, but then everybody is doing that. Okay, so that's it for today.